You this general form, two squared terms, a positive 2x, a negative 54y minus 80 equals 0. Jeremy, what would you do first? Yeah, pull those x's and y's together and notice that the x term doesn't have a coefficient in front of the x squared. So that's good. And Jeremy, what are you doing with the y's? Yeah, what kind of 9 would you pull out? A negative 9. Yeah, so we'll pull out a negative 9 because it's a negative y squared. So that makes it a positive y squared, a positive 6y. Make sure you're switching the sign. And then the last thing, take that 80 to the other side as well. So make sure that you're pulling 80, not 8, to the other side. Jeremy, what numbers did you use to complete the square? Yeah, so +1, a +9, which on the other side means you're adding. Or how about subtracting? 81. And you're subtracting because it's a negative 9 in front there. So be careful with that. You're taking negative 9 times 9, so you're subtracting an 81. So when you complete the square with the x's, you end up with x plus 1, quantity squared. Completing the squared with the y's, we get y plus 3, quantity squared. And then on the other side, you get 0. Yeah, you get a big 0 over there. What is it supposed to be, Peter, for it to be an ellipse in standard form? Yeah, and can you divide by 0? Heck no. No, no, no. Can't divide by 0. And there's no way to make 0, 1. It just doesn't work. 0, 0, it's never 1. So that means, did you do something wrong, Peter? No, but what could you do? We could divide by 9, but we're going to actually keep that 9 there. But yeah, we can divide by it, I guess, Peter. Let's do that. So he said divide by 9, divide by 9, divide by 9. So we'll do that. That's fine. So we have x plus 1 squared divided by 9. This is now minus y plus 3 squared. It's only divided by 1. It's still equal to 0. Just dividing by 9 doesn't change it to 1. It's still equal to 0. So it does give you an a and b value. But if it's not equal to 0, it's not a hyperbola. A hyperbola must be equal to 1. There is something, though, that you can do with this problem. Notice that you have 2 squared terms on the left and something that's equal to 0. So, Peter, what else could you do with the problem? Yeah, so he said he used the equation of the asymptotes to find out what the equation of the asymptote would be. And then that would become the line that would be created from this. So just kind of looking here, when something's equal to 0, there's nothing on the other side but the number 0. You can take that y and add it to the other side. I can isolate the squared terms. So I have 1 squared term on the left and 1 squared term on the right, except that this one isn't squared because I missed it. And then if you have a squared term on the left and a squared term on the right, algebraically, Hannah, what could you do? Just like, why did you pick on me? Yeah, if they're both squared, if both things are squared on both sides, what could you do with them? Darby? Yeah, we could square root both sides because right now both terms are squared. I just have 1 on the left, 1 on the right. We could square root both sides. And if you do that, you end up with x plus 1. That's still a quantity being divided by 9, Or I'm going to say it's a quantity being multiplied by 1/3, not divided by 9, because you have to take the square root. But now it's a quantity being multiplied by 1/3. And because you took the square root, that 1/3 is a plus or minus 1/3. On the other side, you have the square root of y plus 3 squared. Well, that's just going to become y plus 3. And then the square root of 1, we know is just 1. So if you take the square root of both sides and then solve for y, you get -3 plus or minus 1/3, and then x plus 1. So Peter said he found the equations of the asymptotes. And this should be the equations of the asymptotes that you found, Peter. You just found them slightly in a different way.
What I did was once I got it, once I divided by 9, it was in the form of a hyperbola double 1.
And yeah, and you just found those equations. Yep, that would work too. Yeah.
Why would the y plus 3 not be equal to 9?
It is, but because you're getting a y like by itself, if I would divide by a negative or divide by a positive, like once one side is plus or minus, a positive divided by a negative is a negative, a positive divided by a positive, like it still has that plus or minus in it. So if I made this plus or minus and like still took it to the other side, it would still in the end give you the same result. Good question. So this is a special case, obviously, that's happening. When you end up getting a 0 on the other side, it is still a conic because it's set up as a conic form. However, it's called a degenerate conic. Something went wrong, it kind of broke down and fizzled, and it didn't create a conic. And it is the asymptotes of the hyperbola, but the hyperbola isn't there. So what's happening is if I had another cone on top, the hyperbola is created when my piece of paper slices through or my plane slices through. The asymptotes are the edge of the conic, the edge of the cone. Well, because it's equal to 0, that hyperbola part is gone. So it's no longer a hyperbola. But I have these two lines that are going on the edge of the cone, one positive, one negative, and they meet at the tip of the cone. So that's where the two are meeting. So the tip of the cone is where the two lines meet. So that would be kind of what's going on with this, which is the center of my hyperbola. If there was a hyperbola where the two cones meet, the center is where the tips of the two cones meet. So like the tip of it really is a piece or a part of the graph. But in this case, it's just two lines. So those lines are skimming on the edge of it. So it's still a conic because it started out in conical form. That makes sense. No, it's a little weird. It only happens like once in a number of problems. It's not an often thing that occurs. But two lines meeting at the intersection of the cones, which represent the center of the graph. So would you have something like that on the test? No, but it's just something to kind of think about what might happen. Any questions? So we are going to, as I said, look at one more example and then just kind of summarize a few things in the notes. So if you want to pull out your packet, we have an example at the bottom of page 15. In the example at the bottom of page 15 says, find the standard form of the equation of the hyperbola having two vertices at 3, -5, and 3, 1. And the asymptotes are at 2x minus 8 and -2x plus 4. So the equation of our asymptotes, I'm going to go back to this equation here. This is technically like unsimplified form, the equation of the asymptotes, because we know that we can get any equation that's looking like this. I could change it to y equals mx plus b form. So any equation of asymptotes, we write them in this form so that you can pick out the center. But you can be given the asymptotes in a simplified form of y equals mx plus b. And that's what these asymptotes are. So we have y equals 2x minus 8 and y equals negative 2x plus 4. Notice the slope is the same. One is positive, one is negative. And that's going to happen. So the slope will be the same. They will still meet. And where they meet would be the center of your graph. So the location of where those two lines are meeting is the center of the graph. So let's see if we can first take the first piece of information, because that's the easier part. If you have vertices at 3, -5, and 3, 1, what can you determine from the vertices, Peter? Yeah, we can find A. And you can find it by visually looking at the two values. You can find it by making a little graph. Kind of depends on how you see things, and that is totally up to you. So we are at 3, 1. And then we are at 3, -5. So those are the two vertices. So from the vertices, you not only can find A, but Jenny, what else could you find from the vertices besides just A? Yeah, the center. So if you go to the middle of those, we know the center, and then we can find A. So Jenny, the center of 3, 1 and 3, -5 would be 3, 2. So we can find the center either by plotting the points or calculating the center, finding the average of the two y values. Again, it's how you see the problem. So the center is at 3, -2. Graphically, you're finding the middle of those two vertical points. And then Peter said we can also find A, and we know A is the distance from the center to the vertices, and that value is going to be 3. You also know, because the y value is changing, that this is a vertical hyperbola. So we know the center, we know it's going to be vertical, and we know the A value is +3. So using that information, let's start to build an equation. So this is vertical. We have a center at 3, -1, and A value of 3. What variable is first when it's vertical? Yeah, the y. So it's going to be what, Joe? And we don't know what it's going to be over yet, because that's where b squared is located. And then it's supposed to be equal to 1. So we know a good bit of this equation already just by having 2 points. Those two vertices, we got the center and we had A. Of course, we still need to find B, which is why you were given another set of information. And that set of information that you're given is the fact that the asymptotes are y equals 2x minus 8 and -2x plus 4. Now, this is a vertical graph. So I'm going to go back up to where we had the two asymptotes listed here. The equations of the asymptotes, yes, the form is slightly different, but we have k plus or minus b over a x minus h if it's horizontal, k plus or minus a over b x minus h if it's vertical. Hi, Jack. Thanks. So we have A, we need to find B. And if I look at my equations of the asymptotes, A over B, I have an A, I don't know a B, that's going to represent something. What does that represent with respect to the line? What is the A over B, Peter? The slope. So that A over B is the slope. I rise A, I run B. That's the slope of our line. So if we know that the slope is A over B, and we know A is 3, what is the slope of our asymptotes? Two or -2. It doesn't matter which one, because you're going to end up squaring B when you plug it in. So the slope of the asymptote, one is at +2, one is at -2. So again, pick either one of those, or you can keep the plus or minus, it does not matter, but the slope is 2. So you're using the slope of the asymptote. The other value doesn't matter because we want to find A and B. And if I have A, I can then find B. So to find B, I would cross multiply here. 2B equals 3. So B is 3/2. So you're using the slope from the asymptote, the fact that it's rise over run, and this rise is 3. Because that's the distance from the center to the vertex. So 3 over B gives me then 2/3. So square it, 2/3, or I'm sorry, 3/2, not 2/3, is 9/4. So now I have y plus 2 quantity squared over 9 minus x minus 3 quantity squared over 9/4 equals 1. And Hannah, I think, was the one who asked this on Wednesday. Do you really keep it like that? If I was graphing, yes, I'd need that B value to be completely in the denominator when we're graphing. But if we're writing something as an equation, we don't keep a fraction in an equation. So the 4 moves to the numerator, because if I'm dividing by 4, it's the same thing as multiplying by the reciprocal. So dividing by 4, multiplying by that reciprocal. So y plus 2 quantity squared over 9 minus 4 x minus 3 quantity squared over 9 equals 1. So don't get fooled. Don't think, oh, well, A and B are the same. It isn't, because that 4 is still part of the B. We're just writing it in a simplified form. Questions?
Now do you not need to find those for both sides?
Nope. So it doesn't ask us to graph it, so we don't need to find it. So we are good to go just by getting that equation. We could do that if you wanted to, but it doesn't ask us to do so. Parker's saying no thanks. If I don't have to, I'm not going to. Questions? So again, the asymptote slope represents either A over B if it's vertical, or B over A if it's horizontal. But look at your graph and think, like, what is your rise? In this case, the rise is 3. So that means I know A, we don't know the B value. Any questions? So the last part, we're going to look at eccentricity. The eccentricity is the flatness of the conic. So how wide is it? How narrow is it? That's what eccentricity is. For a hyperbola and an ellipse, eccentricity, and a parabola and a circle is C over A. So you're taking the ratio of the focus compared to the vertex, the distance from the center to the focus compared to the distance of the center to the vertex. That value has to be bigger than 1 for it to be a hyperbola. And think about it, it makes sense because C is bigger than A. So that number is going to be bigger than 1 because the C value is larger. A larger number divided by a smaller number is going to be bigger than 1. So down below, we're going to do a little summary of eccentricity. And the first one says E is equal to 0. E is equal to 0 when the conic is what? Think about the 4 conics. Eccentricity is the distance from the center to the focus, C, and the distance from the center to the vertex, A. Why would an eccentricity be 0 for one of those conics? Peter? Why would it be a circle? Does a circle have a focus? No. So the distance from the center to the focus is 0 because there isn't foci in a circle. So when the eccentricity is 0, you have a circle. The other reason the eccentricity is 0 is because it's the flatness of the conic. Well, a circle is round. It's the same distance from any point to the center of the circle. So it's not going to be more flat horizontally, or it's not going to be more narrow vertically, because it's the same distance all the way around. The second one in the middle, if E is between 0 and 1, then it's an ellipse. And there's two parts that we can kind of branch off. If it's close to 0, apparently spelling is tricky for me today. The graph is circular, or close to being circular. And if it's close to 1, then we call it elongated. It's wider, it's a skinnier ellipse, it's more stretched vertically or horizontally. If eccentricity is greater than 1, that's a hyperbola. If that value is close to 1, it's going to be a narrow graph. The branches are going to be narrow. So the closer the focus is to the vertex means the more narrow the branches will be. If E is large, that means my focus is way apart, way separate from, further away from the vertex. And we have wide branches. So there's one conic that's left out here. And I'm not really sure why I forgot about it. What happens if it is 1? Well, that's when it's our parabola. And that's because the distance from the center to the focus is the same as the distance from the center to the directrix. So that distance would be 1 because it's the same distance anywhere on the graph. So the very last part here, after we can kind of think about our eccentricity and what it does to the graph. So eccentricity really affects the ellipse and the hyperbola. It's 0 for a circle and it's 1 for a parabola. So it really is the ellipse and the hyperbola that's making it a wider or more narrow conic. So the last thing I said we were going to do is try and classify conics in general form without doing work. So this means you shouldn't have to complete the square to know the conic that you're trying to get in standard form or graph once it's in standard form. And there are 4 conditions because there are 4 conics. So the first one says we have a circle, and this form here, this is the general form when it's equal to 0, when it's expanded. So think expanded form, general form, big form, all the variables by themselves. We have ax squared plus cy squared plus dx plus ey plus f equals 0. All those variables are just constants, they're numbers. We are going to focus on the 2 squared values because that really is what determines our conic. So for it to be a circle, A and C, the number in front of the squared terms, must be the same. So if I'm saying A is equal to C, that means they're both 3, they're both 5, they're both 4, but they are the same value for it to be a circle. And that needs to happen because I have to be able to stretch the same distance vertically as I would horizontally, so I have the same distance going all the way around from the center. For a parabola to exist, it says the value of A times C must equal 0. Either A is 0 or C is 0, but not both. And an easier way of saying that is that you must have one squared term. Either x is squared or y is squared, but not both. So you only have x squared or y squared. That's what makes it a parabola, because in a parabola, it's just one side. It either goes up, it goes down, it goes left, it goes right, but there's not two of them. It's not connecting like a circle or an ellipse, or they're not going the opposite direction. So parabola has one squared term. And then the final two here, the ellipse, we know an ellipse has a plus sign in the middle. So when you take the values of a times c, they need to have the same signs, because when I multiply them together, it has to be greater than 0. So the key there is thinking they have to have the same signs, both positive, both negative. For it to be an ellipse, you must have the same signs. And then for it to be a hyperbola, the signs need to be different, one positive versus one negative. So a circle, a and c are exactly the same. The x squared terms have the same coefficient. A parabola, one squared term. An ellipse, they're both positive, they're both negative. And then a hyperbola, you have one positive and one negative. So if you look at the three problems underneath, without doing any work, can you determine the graph? Classify the conic. So focusing on the squared terms, what conic are you given in general form? So the first one, 4x squared minus 9x plus y minus 5 equals 0. Parker, what is going on with that first one? What conic do we have?
Parabola.
Yeah. How many squared terms are there? One. This is a parabola. Aiden, how about letter B? And that's because, yeah, one's positive, one's negative. And then Brenna, how about letter C? Yeah, that one's an ellipse. So as I said, the last part of the book homework is classifying the conic. The last part of the worksheet is classifying the conic. It should take you seconds to do. Looking at the two squared terms, thinking about what's going on with those two squared terms. Are there questions? So I'm gonna just pull up the review worksheet. Again, there's really 3 problems from the book that you're actually doing work for. And the 3 problems from the book, you're given information about the vertices or the foci or the hyperbola, or I'm sorry, the asymptotes. And you'll be finding that information and getting a standard form. And then there are a few problems from the worksheet, which I'm going to pull up for you. And they are still working with a hyperbola. And there are 4 problems from the worksheet. So 7 problems you're actually going to do work for. The other problems, it's just identifying the conic that you're given. So if you want to go to Google Classroom and open up that review worksheet, there is an answer sheet provided so that you can check your work. Yeah, that's exactly it. And then I also placed a formula sheet on the front here that we'll probably talk a little bit about on Monday. You don't need to do that right now. But we are going to look at so number 5, that's one of the ones that you're going to do. So circle number 5. Number 10. That one's already in standard form. You just have to find the vertices and the asymptote. It doesn't even say to graph. So it's in standard form, finding the vertices and the asymptotes of that conic. If it has asymptotes, it's a hyperbola. Number 12 says find the equation of the hyperbola with vertices and foci. Come on, Google Classroom here. And then the last two, 15 and 16. So 15 says find the necessary points needed to graph the conic accurately. That means you'd find the vertices, you'd find the foci, you'd find the asymptotes. And then you make a sketch of the conic. And again, number 15 is in standard form as well. I apologize, my Apple TV is just not liking me, I guess. And then number 16 is the one where you're identifying the conic, identify the graph. So you have a couple of minutes, maybe you can work on the last, like number 16 and go through and identify everything. On Monday, we will summarize all of the conics and just work on reviewing for your test on Tuesday. Are there any questions?